project is called Omega. It's for coastal cities to transform solar energy into sustainable biofuels, electricity, and heat, to expand food production and access to clean water, to eliminate pollution and enhance the coastal environment. Ultimately, it's a project to develop sustainable green economies. Let me tell you how it works. Omega uses protected bays like San Francisco Bay, vast areas which will get even bigger with sea level rise. And most importantly, they already have wastewater treatment plants that currently dump wastewater into the bays. But for Omega, this wastewater is a resource, redirected into floating clear plastic tubes to grow microalgae, the fastest growing plants on the planet and the best producers of oil. The algae grow using nutrients in wastewater, and they use concentrated CO2 from a source like flue gas, which means Omega treats wastewater and captures and controls a major greenhouse gas. The Omega infrastructure is used for solar electricity and concentrated solar thermal. And in some locations, wave-powered generators and wind turbines will also provide power. In addition to energy, the Omega offshore platform supports aquaculture and produces high-quality food without using land and without using water. In fact, saving water is a big deal. It's estimated that by the year 2030, half of all the people in the world will face water shortages. And the current map of water scarcity shows in red that there are already many places in desperate need of clean water. Adapting methods developed for the space station for recycling water, Omega transforms wastewater into clean water using 1/3 the energy required to make clean water from seawater. Think about it. The integrated Omega components are modular, and they can be scaled up without using land. For example, the wastewater from one of the treatment plants in San Francisco will support a 1,280-acre Omega system and produce between 2 and 6 million gallons of biofuels each year. And what will be the environmental impact of a full-scale Omega system? It will be like a huge kelp bed or floating reef that will provide a place for organisms to grow and forage, a refuge and nursery for fish and birds. So it is likely to increase local biodiversity and even enhance commercial fisheries. Omega improves the environment by treating wastewater and capturing CO2. It increases the availability of clean drinking water by recycling wastewater. It supplies food without competing with agriculture. And it provides solar energy as electricity, heat, and biofuels. All things that help move us toward a green economy and a sustainable society. Omega, it's more than a dream. From 2009 until last year, Omega feasibility studies were funded by NASA and the California Energy Commission. And the Omega research team did a lot. We engineered floating plastic bioreactors to grow algae that cleaned wastewater and made biofuels. We built remote control systems and developed harvesting methods. We studied the strength and durability of critical materials, the fluid dynamics of different designs, the effects of biofouling and of cleaning, the impact of toxins from wastewater, and the role of pests that eat algae on the system's productivity. Basically, we monitored, measured, and manipulated everything we could think of for laboratory and tank experiments. And we did some experiments offshore to explore the impact of Omega on the marine environment and the impact of the marine environment on Omega. We also did techno-economic analyses to determine the returns on investments for products and services from Omega. I summarized this work in my TED Global talk. And you can find links to our publications on our Facebook page. This Omega system is the answer to sustainability for coastal cities.